Good morning, all of you. I am D. Samsuddin Ansari, Department of Electrical Engineering. I am doing PhD from Bir Sundasai University of Technology. My This is my conference paper. My topic is modeling of fractional order PID controller and study the application of coupled spherical tank level control. My paper ID is 50. This conference is organized by Silicon Institute of Bhubaneswar, IEEE CCPIS 2023. My first slide is about introduction. In introduction, since last few years, level and flow control in a tank is most of the challenging control problem in most of the process control. In this topic, a fractional order proportional integral derivative controller is proposed to control the flow of liquid in a coupled tank system, which is very useful in petrochemical, water treatment plant, as well as in paper industries and process industries. Here we have chosen a two spherical tank which is used due to the higher storage capacity. Due to its variation of the surface, it adds more non-linearity to the system. And this finally a comparison at last a comparison is done between the conventional PID and FOPID, and we have done the means calculated the rise time, peak time, and overshoot also. Here one of the authors, Soumyaranjan Mahapatra, presented non-linear system with spherical coupled tank, which is very challenging one, and many other authors also conducted so many conference and journals from this topic, and by adding the disturbance they have done many more research about this topic. First of all, i need to go I need to go next slide, that is objective of level measurement. What are the needs? Why we used to measure the level management? Level management is important to monitor as well as the measure quantity the liquid content. We can use in reservoirs, as well as level of fuel tank in aircraft to control the level in the tank, as well as we can use also in paper industries and chemical industries. Next, our slide is about the mathematical modeling of spherical coupled tank system. Here I have calculated the mathematical model, and by analyzing this equation, first of all, for I find for the tank 1. Here A1 is the area, H1 is the height of the tank 1, and F in 1 is the input flow of valve 1. By linearizing the above equation 1, we can get A1 H1 derivative of del H1 by dt equal to F1 Fin1 minus F1 H1 minus H2. And by taking partial differentiation and rearranging the above equation, we can find this equation by applying the Laplace transformation. Similarly, for tank 2 model can be expressed as this equation. By combining this for tank 1, this equation 1 and this equation 2, we can get the transfer function that I have put it in the MATLAB, and finally I have simulated it and I have got the result. Next, our slide is what I have proposed model. That is this is the my proposed model. Here FT stand for flow transmitter. Here CV stand for control valve, and CV2 similarly stand for control valve 2, and this is the FT again flow transmitter. Here one reservoir is there. Here water is stored here. From similarly there are two pumps which is going to going to pull the water to the tank 1, and similarly tank 1 will pull the water to tank 2, and then tank 2 will fill the our reservoir. And by this DPT stand for pressure transmitter. This is the pressure transmitter, and this MB is the measure valve, and this is the measure valve 2. Finally, let us go to our next slide. This is the proposed parameter value which I have put it in the MATLAB. My proposed data is Kp equal to 14.3529 and Ki is 0.077377 and Kd is minus 5.75235 and my lambda L is 0.914 and mu is 2.1881. By putting these value, I have got the better response as compared to some reference. They have done better way, but I have got the most perfect response for this model. I am going to show that. Let us move to our next slide. This is our result and simulation section. In this I've given a step input to the summation block, and this is the fractional PID controller. In this PID, proportional, integral and derivative, these are the three different controllers which are going to control, and lambda and mu are the another parameters that are going to again minimize the error, and it will give the more exact and efficient result. These are the transfer function which I have designed in the mathematical modeling, and this is the scope in which we are going to see the response. In this response, our time versus liquid level in centimeter, that is time in second, I am getting the perfect steady state error is minimized, and I am getting the desired value. In this, at 0.25 we are getting the desired value. I've drawn for region 1, region 2, region 3 and region 4. I've categorized one whole spherical tank I have divided into 4 parts. And this is the proposed PID response for 4 regions for step input with objective function IAE. IAE stands for integral absolute error. And these are the reference PID response of 4 regions for step input with ITAE. ITAE means integral time absolute error. These are the optimization objective function that will minimize the error, and then we will get the fast and exact desired value. I have applied GWO algorithm, Gray-Wolf optimization. In Gray-Wolf optimization, first they will search for the prey, and then they will run to catch it, then finally they will attack to the prey. This way the gray optimization technique is work on. Then our next slide is proposed data. These are the proposed data which I have got from the reference, that is Kp is 14.88555 and Ki is 0.045682 and Kd is minus 4.78077. This is for region 1. Similarly, region 2, region 3 and region 4. These are the control parameter of PID, proportional, integral and derivative controllers. Then proceed to next slide. Finally, conclusion. In this topic, a fractional order proportional integral derivative controller is proposed to control the flow of liquid in a coupled tank system, which is very useful in petrochemical, water treatment and paper industries, and many others are also there. We can use in aircraft also. and as well as we can use in chemical industries. Many pharmaceutical chemical industry for making medicines also we can refer this level control. Here, spherical tank is used due to the high storage capacity. I've used spherical tank. There are many researchers are using cylindrical tanks, some triangular tank, but I have used spherical tank due to its variation. Because in spherical means at one position there are means variation in its surface. It adds more non-linearity to the system. Finally, a comparison is done between the conventional PID and FOPID. Then I find out the rise time, peak time, settling time, and peak overshoot. At last, I perform with the objective function, which one is showing the better result. In my research, IAE, integral absolute error, has the better performance indices as compared to other objective function. I have used ISC, integral square error, ITAE, integral time absolute error, ITSE, integral time square error, IAE, integral absolute error, which is the best fitness function. Means that this objective function is giving the best result by minimizing the error. Here we are taking the absolute. Why we are taking the absolute error? Because sometimes error may be negative also. So by negative we can, if you take absolute, then it will be positive. And finally, by summarizing this all conclusion, I am going to end my with reference. These are the reference that I followed. Uh, it 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 takes me to read, and finally uh, gives a better results by following this reference. Among these are the inverted optical design of a fuzzy PID controller for inverted pendulum system. In this inverted pendulum, these are the inverted pendulums. These are the using fuzzy PID controller, and these are the novel fuzzy fractional order PID controller for non-linear interacting coupled spherical tank for level process. This I've referred these papers, as well as I've taken some idea from all of the this reference. Okay, finally, thank you all of you by attending my seminar. Thank you all.